We're going to be looking at proportional reasoning, and the method we're going to use is graphing. The overall expectation is to solve problems involving proportional reasoning, and our specific expectation is to solve problems involving ratios, rates, and directly proportional relationships in various contexts. We're going to use some dynamic software for the graphing part. So we have our inquiry type question, and we're going to read through it once. And then the second time through, we'll highlight what's important. It says, a standard punch requires 2 cans of orange juice and 1 bottle of ginger ale. Okay? When using 4 bottles of ginger ale, how many cans of orange juice are needed for the punch? Okay, this one's a little more straightforward than other questions we've been doing. A standard punch requires 2 cans of orange juice. Okay, 2 cans of orange juice. And what I'm going to actually do when I'm highlighting, I'm just going to highlight the other one in a different color. And 1 bottle of ginger ale. That's important. When using 4 bottles of ginger ale, so ginger ale we highlighted in blue, question asks, how many cans of orange juice are needed? Okay, so let's kind of categorize what we have here. We have our orange juice, which we'll do in red, so we have our OJ, and it's in cans. Okay, so cans of OJ, and our ginger ale, so GA, and that's in bottles. That is a lot now that I think about it. It's an entire bottle. Anyways, for building this punch, we have to set up a ratio. And because we're going to use graphing, we want to kind of build an equation out of this. Now, this is a directly proportional relationship, okay? Direct variation, which means we're going to be using this type of formula. Y is equal to m, and m stands for the rate times x, okay? So our rate, we need to figure out what our rate's going to be. Since we already know it's 2 cans to 1 bottle, that sets up perfectly, okay? So what we're going to say is we're going to say OJ to ginger ale. So OJ's per ginger ale. So if we were to say that, OJ's slash ginger ales, and the per means the number 1. Well, it works out great. I guess I should do it in green because it's ginger ale we did in green. Okay, works out great because our ginger ales are already set up as a value of 1. So we need 2 cans. So right away, we don't even have to do anything. We know our m in this case is the value of 2. So our equation reads y is equal to 2x. Okay, so we've built our direct variation ratio. So let's put it into our software here. So I'm going to write y equals 2x. So here's our y equals 2x. I've already put it out. Okay, and actually we should state what that means also is that our ginger ales are our x value. They're the independent variable, which means our OJs are our y-axis and they are our dependent variable. And that'll make a lot more sense when we come over here. So since our independent is our ginger ale, and our question was asking for 4 bottles of ginger ale, we're going to type in x equals 4. And at first, I could actually just follow this up to the number 4. And as you see at 4, we need 8. But it's kind of hard on this program to do that. So instead what I'm going to do is when x is equal to 4, where they intersect each other, this point right here is our x's being our ginger ales, and our y's being our OJs. So apparently we need 8 cans of orange juice for 4 bottles of ginger ale, which makes sense because it was a 2-to-1 ratio in our question. Okay. If you'd like to see other ways to solve this question, just look at our other playlists on proportional reasoning.